Okay, good morning. Welcome to
SuperMath148.
SuperMath148. So I just was glancing in your book. Oh, we started a new section today called Power of a Point. And I was glancing at the problems, and this was a star problem. And I was kind of surprised because looking at it, it didn't seem hard. But when I just quickly worked through it, I saw why it was not super easy. So it says I've got a point outside the circle. And I know that these two lengths are equal. BC and DE are equal. And I want to prove that AB also then becomes equal to AD. Okay? So what do you think, before we start writing stuff down, what do you think you're going to use to prove this?
Well, we learned a new theorem that says if you have something like this with lengths this length is x and this length is y. And actually that won't really work. I'll just use it here.
Okay. You can write down the actual segment lengths if you want.
So we have segments. So for our theorem it says AB times AC actually equals AD times AE.
Yeah, and so here we have a lot of unknowns. We know BC and DE are equal. What should we call that?
We could call that 1, or we could call it x.
It's an interesting observation, actually.
We could give
You may as well call it 1. I like that. You don't know what it is, so let's just call that distance. We'll scale the whole problem so that that distance is 1. So I can kind of zoom in or zoom out on it. Okay, that distance is 1. How about AB? What do you want to call that? We don't know what that is.
Let's call that x.
X, and what about AD?
AD we could call y.
Y. Okay, great. So, yeah, actually your solution's better than mine. Calling that 1 is a very good idea. Okay, so what does our theorem tell us?
Well, AB is x, so x times 1, x times x plus 1 is the whole thing.
Okay, so that's very important to remember. It's not AB times BC. It's AB times AC. Okay, so it's x times x plus 1
equals y times y plus 1.
parentheses. Okay, great.
So we get x squared plus x is y squared plus y.
X squared plus x is y squared plus y. And you can, without going into detail, you can imagine, like, if I called this a third variable like z, we would now have an even more complicated equation. Okay? And so we're trying to show that x has to equal y here. How do you think you're going to do that?
Well, we could do it, we could say x squared minus y squared equals y minus x.
Okay.
And then we get a difference of squares,
All right.
so we could do that.
I'm going to make just a small suggestion that instead you set it equal to 0. So you get x squared minus y squared plus x minus y equals 0.
Alright.
Okay. All right, what can you do now?
Well, we can do a difference of squares.
All right, how does that factor?
So we get x plus y times x minus y plus x minus y equals 0.
All right, what can you do now?
Well,
This is the trick on this problem. This is the subtle trick on this problem. What do you do now?
well, we have an x minus y here and an x minus y there.
Okay, great, so factor that out. So
So,
this is equal to what? X minus y times what?
what should I erase?
You can write it right up here if you want, but just step over just a little bit.
So, this is x minus y times x plus y times plus 1. And then equals equals 0.
Okay, so it's been a while since we talked about algebra, but now I have a product that's equal to 0. Do you remember what that must mean?
Well, that means either this or this is 0. Like that. Either this or this is 0.
Right. If a product is equal to 0, one of the two terms has to be 0, or maybe both of them can be 0.
But here
the only numbers that multiply to be 0
are something and 0.
something times 0. Okay?
Well, here we know it can't be 0 in this term.
Why not?
Because we're talking about distances, which are positive distances.
Talking about positive distances. So x plus y plus 1, we don't know what that is, but it's positive.
So this has to be 0, which means x equals y.
X equals y. So that's pretty cool. So it's a neat consequence of our, I haven't explained why it's called the power of a point, but it's the neat consequence of this outside of the circle point theorem. That if the chords inside the circle are the same, then the line segments outside the circle have the same. It's actually pretty cool. That's a subtle little problem, actually. But remember, it's when you're outside the circle, it's the short segment times the whole segment. And as I explained when we were talking about it, it's the same thing inside the circle. You're always measuring from the point. That's kind of the hint as to why it's called the power of a point. Okay? Alright, good work this morning then. Fun. Always fun to start a new chapter.